Hello viewers, hope you people are having a very good time in solving mathematical problems. So this is your Subhash. So this video lecture is going to be the part 2 of the previous lecture. So the part 1 we are giving in the description link, so users can go and refer it. The main summary of the today's discussion is on the Pythagorean theorem and how it can be applied on solving Olympiad problems. So today we are going to discuss some interesting problems related to PRMO, and we have also chosen Hong Kong Olympiad, and we are going to discuss many problems on that. Introductory part of the theorem we have already described in part 1, so users can anytime revert back to part 1 and they can go through all the preliminary problems. The problems which we have chosen for this part are going to be slightly more difficult when compared to part 1. So already we presume that users know what is the Pythagorean theorem, which is specific to right angle triangle. That is nothing but square of the hypotenuse is equal to sum of the squares of other sides. So having said that, let's move to the problems. First problem is very interesting problem. Let ABCD be a convex quadrilateral with perpendicular diagonals if AB is equal to 20 and BC is equal to 70 and CD is equal to 90, then what is the value of DA? So as I've already told, whenever we are trying to solve a particular geometric problem, we have to make a neat diagram. And here we are going to label all the values. The value of AB is 20, the value of BC is 70, and the value of CD is 90. If you see here, the problem is not that straightforward because we have to calculate AD and there is no way to calculate AD. There is no way to calculate AD. So the main gist of today's class is how we can develop simultaneous equations in trying to solve geometric problems which revolve around measurements. Here if you see, ABE is a right angle triangle, BC is a right angle triangle, DEC is a right angle triangle, AED is a right angle triangle. Many possibilities come here. But can we narrow down all the possibilities and arrive to the solution? Let's see. So considering the right angle triangle ABE and BEC, can we make any particular relationship? So we can say AB square minus AE square is going to be equal to BE square. Considering the right angle triangle ABE, we are again going to consider the right angle triangle BEC, where we are going to say BC square minus EC square, BC square minus EC square is also equal to BE square. Can we equate both of this? AB square minus AE square, which is equal to BC square minus EC square. Can we put something like ED square minus ED square on both sides? Let's see what happens. So users can just pause here and just observe how we have derived it. So AB square minus AE square minus ED square minus BC square EC square minus ED square. Here if you see, AE square and ED square are related. AE square and ED square, if you combine them, it becomes equal to AD square, and EC square and ED square, if you combine, it becomes equal to CD square. So we can apply the Pythagoras theorem for this particular section. Okay, and we can change the above equation. AB square AB square minus AD square is equal to BC square minus CD square. So we are going to get AB square plus CD square is going to be AD square plus BC square. Very important lemma actually. Okay. We find application of this in many problems. That is nothing but sum of the squares of opposite sides. AB square plus CD square is same as AD square plus BC square. People should remember one thing, this is only applicable when the diagonals intersect perpendicularly in a quadrilateral. The quadrilateral need not be rhombus or a parallelogram specifically, but when the intersection happens perpendicularly, then we can apply it. Okay. Now taking this into consideration, we have AD square plus BC square, that is nothing but 70 square, is going to be equal to AB square plus DC square, that is 90 square plus 20 square. Okay, 90 square plus 20 square. So eventually we are going to get AD square is going to be equal to 3600 and AD is going to be equal to 60. But here what we want to emphasize is sometimes same idea can be reused in some other problems. Probably this particular thing is not a problem, but we can call it as more like a lemma where it can be reused in many problems. So we have found this pattern in some other Olympiad problem. So we want to demonstrate that. So let's go to another problem. This was a problem which was given in Hong Kong Olympiad preliminary selection test. It is equivalent to our PRM or IOQM. So there is a trapezium ABCD where parallel sides CD and AB are the parallel sides. CD is perpendicular to BC and AB is also perpendicular to BC. Diagonals intersect perpendicularly. Here comes the gist of the problem. Okay. To solve this problem, we will do one thing. We can make a small construction. We can draw a line parallel to the base BC and we can name this something like, let us say F. Okay. We'll call this as F. So this is also 90 degrees. So here we can say ABCF is a rectangle. Now let us say CD, the length of CD, let us say is equal to Y. So we can say that the length of DF is going to be equal to Y minus root 11. Because CF is also going to be equal to root 11 because it's a rectangle, opposite sides are going to be same. The value of DF is going to be Y minus root 11. So users can pause here and just to see how we have made the relationship. Now let us label BC as X here. So we have one equation ready for us. X square plus Y minus root 11 whole square is going to be equal to 1001 whole square. Got it? This is first condition. Second condition. With one condition we cannot solve the problem. We need more conditions. So can we really find the pattern? Here, whatever analysis we have done in the previous problem can be reused in this particular problem also, because here the diagonals are intersecting perpendicularly. So the sum of the squares of the opposite sides are going to be same. Taking this into consideration, we have x square. The opposite side is going to be square root of 1001, that is going to be equal to y square plus 11, square root of 11 whole square. So we can subtract both the equations, and after careful transformation we are going to get a quadratic equation which says y square minus square root of 11 into y minus 990 is equal to 0. So this is the quadratic equation. Now can we solve this quadratic equation? Yes, it's possible by applying the formula for finding the roots of the quadratic equation. The value of y is going to be equal to square root of 11 plus or minus b square minus 4ac, that is nothing but 3971 divided by 2. Here the value of y is going to be equal to 10 root 11. After finding the value of y, which is equal to 10 root 11, can we find the value of x? That is what the problem is demanding. That is nothing but the length of BC. So we can plug in the same value in the equation 2. The value of y, if you substitute 10 root 11, finally we are going to get the value of x as equal to, this can be easily done. We request the users to substitute the value of y as 10 root 11 in the equation 2. So finally you are going to get x is going to be equal to square root of 110. That is the answer for the particular problem. So here one thing we want to say, that many times it so happens that one idea used in a problem can be reused in another problem. And not only that, if you take any RMO problem or if you take any INMO problem, national level Olympiad problems, the ideas which went inside the problems where we solved for PRMO and all become subsets of those problems. So first we have to get command over the problems which are of PRMO level, AMC level, then we can go to the higher level Olympiads. That is what request we are making to the users. So users can pause here and just they can go through the derivation once. Okay, so we go to the next problem. That is also a very interesting problem. Hong Kong Olympiad has got two sections, 1 mark section and 2 mark section. So here, if you observe, in triangle ABC, DEF are respectively the midpoints of AB, BC, CA. Okay. Furthermore, AB is equal to 10, CD is equal to 9, CD is perpendicular to AE. Find BF. So we have constructed the triangle, we have constructed the medians, we have named the centroid as G. Now let's revisit the properties related to the medians and the centroid. Centroid is a point which is nothing but the center of the triangle. It divides median into 2:1 ratio. Median is nothing but the line which connects the vertex to the opposite midpoint of the opposite side. Here in the problem they have given that the length of AB is going to be 10 units. So AD is going to be equal to 5 units. DB is going to be 5 units. They have given the value of CD is going to be 9 units. Since G divides CD in 1:2 ratio, we can say CG length is going to be 6 units. This is going to be equal to 3 units. Now, how can we continue this problem? If you see this problem statement, it has been clearly told that CD is perpendicular to AE. If CD is perpendicular to AE, there is a scope for applying Pythagoras theorem here. Let us say we will name CF as equal to B, AF also equal to B, because midpoint divides CA into two equal segments, and CE we are naming it as A and A. Is there any possibility of putting simultaneous equations for this two triangles? That is nothing but right angle triangle AGC and another right angle triangle CGE. Users can pause here and just can they observe once. Okay, here we go. Square root of 4b square minus 6 square is going to be equal to, we can say equal to AG. Similarly, square root of mm, A square minus 6 square is going to be equal to G. And it's a well-known fact that AG is twice of G, because centroid is going to divide the median into 2:1 ratio. Now let's put that idea into place. 4b square minus 36 divided by A square minus 36 is going to be equal to 2 by 1. So this can also be rewritten as 4b square minus 36 divided by A square minus 36 is going to be equal to 4. So which eventually becomes equal to A square minus B square happens to be equal to 27. This is one condition here. Second condition, is there any possibility? We request the viewers to observe it very keenly. Okay, we are going to explain. There is something called length of the median principle. Can we reuse it? Let us say if there is a triangle ABC, we want to find the length of the median AD. That is nothing but the yellow color line. So users can refer to the chapter properties of triangles, where by applying cosine principle we are going to find the length of AD. In short, the length of AD becomes equal to AD is going to be equal to, without loss of generality, AD is going to be equal to half of square root of 2b square 2c square minus a square. Here small a denotes the side opposite to vertex A, small c denotes the side opposite to vertex C, small b denotes the side opposite to vertex B. So when you have to calculate the length of the median connecting the vertex to the opposite side, this is the formula. Now is there any scope to reuse this formula? Yes, it is possible. So here comes, again we are emphasizing, many times it so happens that certain formulas become subset in solving a particular problem. So here we are going to develop another equation here. So users can observe here. Okay. So the length of the median here is 9 units from C to AB. So 9 units are going to be equal to square root of, we'll rewrite it, half of square root of, putting the same values here, just users can see this particular formula once again. Half of 2b twice b square twice c square minus a square. The side opposite to the vertex is going to get the negative symbol here. So putting all the things together, now users can see 9, which is equal to 1 by 2, is going to be equal to 8 times b square 8 times a square minus 100. So after careful manipulation, this leads to a condition a square plus b square is going to be equal to 53. This we will call it as condition 2 here. The first condition is a square minus b square is 27. The second condition which we got just now is going to be a square plus b square is going to be equal to 53. Now after solving these two equations, we are going to get a is equal to 2 root 10 and b is going to be equal to square root of 13. Now, how can you find length of BF? This we are not going to solve. We are going to leave it to the user. The hint is again this particular theorem which is used for finding the length of the median can be reused in this particular problem. So once we have all the dimensions of the triangle, finding length of any median is very straightforward. We can reuse the same formula, but only thing is that the value of the sides change here. Okay. So hope you people had a great time in solving and observing all these problems. So we expect a very good feedback from the users, and they can kindly subscribe to our channel Bhaskara Mathematics. If they feel that these two lectures are very useful, they can put it in the comments. We have many problems. We have many senior faculties who have solved many Olympiad problems. We are going to publish as per their interest. If it could be congruence of triangles, or if they want more problems in the Pythagoras theorem also, we are going to publish. We are going to give assignments, and not only that, next following lectures are going to be very interesting. So kindly subscribe to our channel Bhaskara Mathematics. So once again, we would like to thank all the viewers for your valuable time.